Good to have you back. So today we are going to talk about applications of conics. I have two questions set up for you. We're going to go through each of the questions. I'm hoping that it will be done under 15 minutes. Stay with me. First question. We have the arch of a bridge has a shape of a rectangular hyperbola. The base is 160 meters wide and the vertex is 40 meters above the base. Find the equation of the hyperbola, then find the height of the arch at a point 20 meters from the center. Okay, so few information we need to extrapolate and then draw the graph, which I have actually done that for you. But the first thing is that this thing right here, this is a rectangular hyperbola basically centered at 0, 0, and that means that the conjugate and transverse axes are same size. Okay, so the equation of the rectangular hyperbola looks like x squared minus y squared is equal to a squared. Now, this is the horizontal transverse axis and a conjugate vertical axis, but in the graph that we have, a bridge, if you think about it, the arch of a bridge can't be horizontal, so we have to rewrite this as either we can write it as x squared minus y squared equal to negative a squared, and that way that would guarantees that that becomes the vertical transverse axis, or you can switch them around and just put down as y squared minus x squared is equal to a squared, which is, by the way, these two are exactly the same. They're identical to each other. So whichever we use, I'm going to use the first one. This one, it just makes it easier. It doesn't really matter. You can use this one. And then we're going to go through and plug numbers in. So notice that 160 meters wide from the base. So if I draw, so I know few information. First of all, 0, 0. I do know that the vertex is 40 meters above the baseline, above the base. So if this is the base, which is the ground, let's say it is the part of the bridge, and this is the flat line, horizontal line. So 40 meters above it, that is the vertex. So I do know that the x coordinate of that would be 0, but the y coordinate of that, I don't know what that is. I just don't know what the drop is from the actual center of that hyperbola. Remember, that's the important information that we need, because the other side of this hyperbola is on other side, on top of this graph, right, which we don't need. We just need one part of it. Okay, so and then the information, 40 meters above the base, and then the information that we have, find the equation of the hyperbola, find and then find the height of the arch at the 20 meters from the center. Well, if that's the center, we go 20 meters right here, you drop down, and then we hit the hyperbola, and that coordinate is 20 comma negative y. We don't know what that y is. Okay, so we have few things to deal with, and then the final answer is that we actually want this height, the r, let's call this rs, okay, for the actual point of 20 comma y2, but y2 is actually minus a minus 40 in the coordinate q. Now we do know that this is 160 meters wide. That means it's symmetric. So this side right here, that's 80 meters. And therefore the other side must be 80. So together is 160. So this coordinate Q has the x coordinate of 80. And then the y coordinate, we just know that it's A. So this part right from here to here, that's your A, or negative A. And then you have to add another negative 40 to it, and then you get that coordinate. Now that we have everything, we're going to plug numbers in into what we have, and then go ahead and solve. So let's go ahead and do that. So we are going to plug in the number, the coordinate 80 comma minus a minus 40 for x and y, and solve for a. Let's go ahead and do that. And then we need to solve for a, and then you have to expand and everything. Let's do that. When you expand everything, this is what you're going to get: a squared plus 80a plus 1600 minus, and then 80 squared is 6400 equal to a squared. And notice that a squared and a squared cancels out. And now you will get ADA equals to 4800. When you do the math, divide everything by 80. By the way, this is supposed to be A, not X. And now we have A is equal to 60 meters. Fantastic. Now that we have that, we know the coordinates now. We can go ahead and plug in numbers for the coordinates because now we can find what coordinate Q and Q coordinate S is. So the S coordinate will be 20 comma and then will be negative 60, negative 40, which is, so S will be 20 comma negative 100. And what is Q? Q as well will be this time 80 comma negative 100. So we have these two coordinates now set up. Very nice. Now we're going to go ahead and solve. Once we have that, we can go ahead and solve for coordinate R and then know, once we know the total coordinate for the R point, which is negative y, we can look at the distance between R and S and then answer the question. But before that, let's write up the equation of the hyperbola. That's y squared minus x squared is equal to 60 squared. That's what that is because we just found a. Remember that was a squared. So this is the equation of the hyperbola that we have drawn. And now we're going to go ahead and solve the value for negative y right here, this value here, which is a coordinate of r. Then we say y squared minus 20 squared is equal to 60 squared. And then from here, you just go y squared equals to 3600 plus 400. So y squared is equal to 4000 and y equals to square root of 4000. And you get y equals to 63.25 meters. That's the coordinate of y, and that's negative, so our coordinate is 20 comma negative 63.25. So now that we have this value 63.25, when you take the square root of 4000, you have the coordinate of the r, and so here it is. Now we have the coordinate r is 20 negative 63.25. But then you also realize that y2 was negative 100. So we want to know the distance between R and S. So we want this distance right there. So what would you do? That's 100 minus that, and then you get that distance. So let's go ahead and find the length segment SR. Okay, so this is S, that's R. We're going to call it length line segment SR. So let's go ahead. That's SR equals 100 minus 63.25, which is equal to 36.75. All right, so that is the final answer, and that's what we were looking for at the end, that it is the point 20 meters from the center. The height of that is 36.75 meters from the center. Okay, so that's the first question. Make sure you go over this diagram again, the question again. Make sure you follow exactly the steps. There are lots of moving parts, and use the rectangular hyperbola form, which is the standard form. You fill in all the missing variables that you're looking for, and at the end you will get it. Okay, next question. Here's the next question. A tunnel is built into a mountain for a road 15 meters wide with a 2-meter sidewalk on either side. So I drew this diagram here. So imagine that's a tunnel, and then this 2-meter right here on this side, and this side, it's the incoming and outgoing traffic, is the sidewalk. So the top of the tunnel is semi-elliptical. So I tried to draw a semi-elliptical shape. The lowest clearance above the road must be 4 meters. Now, what does that mean? Well, this distance right here, this is the lowest because it's still on the road. So this is the road, right? So this part is the road, That's the road. So the lowest part, this distance from there to here, that should be 4. It cannot be. So as the other side, right? So that one is also 4 meters. Okay. So both of those, they must be 4 meters. All right. And it says if the smallest possible ellipse is used, find the clearance at the center of the road. So basically what we want to get the top value right here, this distance is. Okay. Now, to do this question, you need to strategically place the ellipse on a Cartesian coordinate where you have a 0, 0 is the center of that ellipse, okay? And it's going to look like this. So you see what happened? I just basically superimposed the Cartesian coordinate to the center of the ellipse. And now everything is easy because the equation of the ellipse is going to look like this: x squared over a squared plus y squared over b squared equal to 1. And it has a horizontal major axis. And what we want to find is this guy right there, b squared. Okay, so let's figure out what coordinates we can use. What are the things that we do have? Well, we do have few things. First of all, we know that this is symmetric. That means this part right here is 7.5. This part is 7.5. The entire thing is 15 meters. That's the road. But the actual value of the major axis, the length of that is 7.5 plus 2. In this case would be 9.5. And on this side will also be 9.5. Okay, that makes sense. That's 15 plus 4. That would be 19. All right, so your A value is 9.5. Okay, so now we're going to go ahead and choose a coordinate and then plug numbers into the standard form of an ellipse, which is right here, and then solve for B. Okay, and what is the point that we're going to use? Well, we're going to use this coordinate right there because it's still giving us that. So let's use that coordinate. What is that coordinate? Is 7.5 comma 4, because that's the lowest clearance that must have. So we know that that coordinate is on the graph for sure. Okay, so now that we have that, we're going to plug this point coordinate. Let's call this P. We're going to take that and this is your X, this is your Y. We're going to plug it back into this standard form of an ellipse and then solve for B because we don't have B. We have A, but we don't have B. Let's solve it. And then once we get B, that is the length of the minor axis. So let's go ahead and do that. So when you write it up, you get this, which is basically the standard form. I just replaced X and Y and A for what values that I have. I have A is 9.5, X is 7.5, and Y is 4. Plug numbers in, and then you get this, and then you want to solve for B squared. So isolate this fraction first. So 1 minus this, and 7.5 squared, you get this value. 9.5 squared, you get this value. And now we're going to finally rearrange and then solve for B squared. Let's do that. You do the math and then you isolate. You get B squared equal to 16 over 0.3767. And remember, when you get that, you want the value of B. That means you have to take the square root of both sides. Final answer, and your final answer will be plus or minus 42.47 meters. Now, when I say plus or minus, of course, we are just looking at the positive part of this ellipse. Obviously, the tunnel is just a semi-ellipse. That means it's the top part. So the negative you ignore. So the answer, so you ignore the negative, and the final answer will be 42.47 meters high. That's the height of the tunnel at the very center of the road, and that is the final answer for B. All right, so that is it. I hope you found this useful. Check out the next video that's got to do with other conics or related topics. Take care.